Got this yesterday. Can someone turn off the front light back there? There we go. Okay. So, related rates. Let's talk about them. All right. So, the one thing that is going to be a little different with related rates. Scroll back up here. But am I on the wrong? Oh, no, I'm on more derivatives. I'm supposed to be on derivative apps. There we go. And of course. So, as I said before, related rates is where we're going to be focusing on using one rate to find another. Okay? Now, we're going to do the same thing. I'm going to list out the steps you can take, and a lot of the times on our quizzes, on my quizzes and tests, the ones that Mr. Miller and Mr. Stark have worked on before, we list these steps out exactly almost all the time. So make sure that when you're doing this, you're actually writing down the steps and understanding, okay, this is when this step happens, this is when this one happens, and then on the homework, try to kind of structure it the same way. So, the key parts is going to be, the first thing is you need to understand the problem. What rates do you have? What are you trying to find? What do you need to know? So here we have understand the problem. What is it asking you for? Then my next step is going to be to, and this is always going to be true, develop a model. You need some form of equation or expression in order to solve these. Okay? Then you're going to write an equation relating the variables. Okay. Once you do this, this is the hard part, right? These three steps are going to be the hard part, just like when we were doing maximization. The hard part wasn't necessarily the calculus. You could mostly do the calculus. It was just setting up the equation from the word problems. Then the next part is going to be where we differentiate both sides with respect to t. Because when we're talking about rate here, we are talking about time. So therefore, we're always going to have to look at a t-value. Connor, can you put that away? Sure. Then, what we do is we're going to substitute in values. And inspect / explain our solution. Okay, so now a lot of these steps won't make sense until we actually get here. So let's go ahead and look at this problem. And one thing that I want to make sure we're doing is always read the problem. In any one of my classes, so many people come up, ask me a question, and I'm like, did you read the problem? And they look at the problem, read it over, and a lot of times their question is answered by them reading the problem. So our example here is a rocket launch. A rocket launching straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's elevation angle is pi over 4. The angle is increasing at the rate of 0.14 radians per minute. How fast is the rocket rising at that moment? Okay? So we need to understand, what are we looking for right now? What are we looking for? What rate are we looking for? We're looking at the rate. Think about it. We know the rate of what? The rate of? What is this saying? The angle. Right. So we know, what's the way we describe an angle? We describe it as theta. So therefore, we know d theta over dt, right? Because what is the rate? The rate is d theta over dt. Then what is going to be what we're looking for? Well, we're looking for how fast the rocket is rising. So are we looking for y or x? We're looking for dy over dt. Very good. So therefore, we know that this right here is going to be our d theta over dt. Very nice. Now we need to develop a model and draw a triangle. Really quick, I want you all to try to draw this triangle. Just take about a minute or so. See if you can draw it on your own. Yes, Lucy?
What does it say under the underline?
dy over dt and d theta over dt.
Okay, I was talking about the underline.
Oh, this d theta over dt. Yeah. Okay, so have we drawn out the triangles? Let's draw them out. Again, I know it sounds like it might not, but drawing the triangle really does help. Okay? So now, when you draw this triangle, I'm going to draw mine this way. We have this triangle here. This is a terrible triangle. But look at, oh, come on. That was going to be great. Look at how good my triangle drawing skills are.
You draw.
Look at that. Isn't that crazy?
That's great.
So, let's label this out. What information do I know? I know how long is this distance here. It is 500. Then, this right here is going to be theta, or pi over 4. Very nice. Then, I know I need to find my y value here. We don't know what y is there. And this all the way up here, I'm just going to draw this. You don't have to do this part. But this is going to be my rocket. So, now we need to find some formulas. We need to find one that relates h and theta. So what formula here is going to relate h and theta? Sorry, not h and theta, y and theta. I used y, they used h. Those are my apologies. Sometimes the variables might, I use y instead of h here. You can use either, doesn't really matter, but
Tangent of
opposite over adjacent. Very nice.
Tangent of pi over 4 equals y over 500.
Wow.
Very nice. So we know that the tangent of pi over 4, good. However, remember, is pi over 4 always going to be our angle? No. So what should our angle be? We should have tangent of theta is equal to y over 500.
But are we looking for how much it's rising at that moment?
Yes. However, we need to first, before we do that, before we input that data, we need to get a rate equation. All right. So actually, that's a good question. I'll have to check. Maybe, you know what? Why don't you try it that way? I'm going to do it this way. So you can input tan of pi over 4, and I'm going to do it this way and see if we get the same answer, because that could be true. So let's go ahead and do this together now, because we know that y is equal to 500 tan of theta. Now, what I need to do, now that I have this formula, I need to differentiate implicitly. So what I want to do here is I have y equals 500 tan of theta, and what are we taking the derivative of with respect to? We always take the derivative with respect to t. With all of these, it is always going to be t. Look here. What does that mean? Well, you know how when we take the derivative of y with respect to x, it becomes dy over dx. Therefore, if we take the derivative of here, instead of d theta over dy, we're going to have d theta over dt. And over here, we're going to have dy over dt. So let's take the derivative of both sides. The derivative of the left side is going to be, what's the derivative of tangent theta? Secant squared theta. And don't forget to also write, what did we just take the derivative of? D theta over dt. Okay? We took the derivative with respect to t. Then this is going to be equal to, what's the derivative of y? dy over dt. Because we want to take the derivative of both variables, not just one, both variables with respect to t. Yes?
Where's t in the equation?
There is no t, not yet. We are adding it in. When we say take the derivative with respect to this variable, that means that is what's going to be on the bottom.
Wait, so the
By adding a dt on the bottom, d theta over dt is asking you, what is d theta over dt saying? It's saying, what's the derivative, as theta change, what is t changing by r? Here's the slope. So theta will go up by a certain amount, and therefore t will go up by a certain amount. We add it in by stating that we are differentiating with respect to t. We usually differentiate with respect to x, because what ends up at the bottom of almost all of our equations? dy over dx. Now we're doing it with t, which means we need to add in that dt. Okay? So now we can start, and this is 500 right here. Almost forgot about the 500. Now all I need to do is the easy part. This is the substitution. 500 secant squared of pi over 4 times my radians are 0.14 is equal to dy over dt. And if you input this in, you're going to get 500, I believe, times, what is it going to be? Is that going to be 4? No. What's secant? Secant is cosine. What's the cosine of pi over 4? 1 over root 2 times 1 over root 2 becomes 1/2, becomes 1/4. So it would be 500 times 1/4 times pi of 0.14. Or you can just use your calculator. Either way, both will work. So you should get an answer of 140. And then what are our measurements in? For y? Well, we measured in feet per. And then what rate are we looking at? Well, what's the rate of theta in? Radians per minute. So therefore this should be in feet per minutes. Because we used the rate of theta per minutes, we changed it to feet per minute because now we have y on the top. However, dt stays the same.
How'd you get 100?
Yeah,
I got 17.5.
same.
Really?
Yeah.
Are you in radians or degrees?
I'm in radians.
You got 140?
How?
Are you in degrees?
It's not very fast.
It doesn't matter if you're in radians or degrees.
Did you try it? Wait, did you try it your way?
No.
Oh,
Okay.
yeah, I got
I did it God's way.
Yeah, I mean, people are getting.
I don't.
Oh, okay, wait, maybe, wait. What's 1 divided by the cosine of, sure, 1 divided by the cosine of pi over 4 squared. Oh, sorry, this should be times 4, not divided by 4. Yeah, this is times 4. If you put this one in, you'll get the correct answer. This one was a times 4.
Mr. Holmes,
Yep.
why is it times 4 if secant squared pi over 4 is 2?
Well, because it's 1 over the cosine of pi over 4. So it's 1 over root 2, which then becomes 1 divided by a fraction. Copy dot flip becomes 1 times root 2 over 1, or just root 2. And then we square that because we have 2 of them, so we get 2. So it's not going to be 4, it'll be 2.
Where'd you get 4?
I was treating this as if the square root of this was 2. All right, so what does this mean? What is it saying? Can someone explain? Oh, sorry, Lucy.
I was just gonna ask if you could zoom in a little bit. Okay, thank
So you got yes, yes, yes.
I think I tried like Cody's way with like the tan and I got 500, but I think it's because that's fine like the height, but this is asking for velocity, which is like
It's the rate, yes. However, because that's a good point, because what do we need in this equation, Cody? We need d theta over dt. If we get rid of theta, can we find d theta over dt?
I guess not.
No, because if we'll be taking the derivative of only one variable. Now, the hard part of this, and I know we're getting to a point where we need to start pushing through, okay, do you understand it fully? No, but we need to know how to do it. Okay? So, if you don't understand, the hardest part of this all for a lot of people is just, why are we dividing by dt? Well, we need the rate, so we're going to divide by dt to create rates. That is the very basic logical reasoning behind it. There's obviously more that we can talk about. But for now, just divide by dt. Yes?
Sorry, so how did you conclude that 0.14 radians per minute is d theta over dt? Like, how do you know that? Is that just like, because...
Well, remember, what is the derivative in the end? The derivative is the what of the original function? It's the slope of the original function, right? And what is slope? Change in y over change in x. And what does change in y over change in x also stand for? Any rate, right? Miles per hour, feet per second. So whenever you see that, you can see, oh, a rate is a derivative already. It's basically giving you d theta over dt at a certain point. So if I evaluated the derivative of the function that gives me the tangent, and then I evaluated at pi over 4, I would get 0.14, right? Okay, so go ahead now. I want you all to start on the next one on your own. A police cruiser approaching a right-angled intersection from the north is chasing a speeding bandit that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with the radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour, at the instant of measurement, what is the speed of the car? So we're looking for the speed of the person who's run. We're looking for the speed of the thief.
80.
Hmm?
Yeah, it's just 80.
So no, because what this is saying is that the distance between them and the car is increasing at 20 miles per hour.
Well, that's just
So
still
now-
80, right?
They're not going in the same
'Cause it-
direction.
They're not going in the same direction.
The
You have to look at the
officer's
stuff.
going down
Yep.
from the north.
So now, what I would actually encourage you to do is look at this and say, well, how many different rates do we have? We have 3 different rates, right? We have how fast the police is going, how fast the thief is going, and how fast the distance in between the two is getting bigger. So we have, how many variables should we include in this? 3. So choose any variables. I chose x, y, and z. So therefore, what are we looking for? Well, what way is the thief moving? Let's see. The car is a speeding bandit that has turned the corner and is now moving straight east. So east stands for what? Do you think x or y or z?
X.
X. So we're going to call the thief x. So what are we looking for? We're looking for the speed of the speeding bandit, which means we're looking for dx over dt. Oh man, I remember doing this problem during the notes now. It is fun. Then what do we know? Well, we know dy over dt. And we need to find, and we also know dz over dt. Okay? Now, I will tell you that it's going to be easiest to draw this in the form of a rectangle. Sorry, no, not in the form of a rectangle. In the form of a triangle. So go ahead and draw it to where your cop is on top. And try your best to picture this. I will draw it in about a minute or so. But do your best to picture what you could kind of draw this out as.
What are Y and Z?
Yeah, what's z?
Well, it's whatever. It could be anything. So dy. I'm gonna say dy. This is the comps. dz is the rate at which your increase is the rate of the in between the two cars. So x is the thief, y is the police, and z is the distance in between them. Is everybody here today? Yeah, everyone was here. Yep. What day is it? It is. It's Friday. That means I don't have to come to work tomorrow. Nice. I'll just stay home.
I mean, if you want to.
So jealous. Did I tell y'all my mom has gotten 2 like 4 snow days already this year?
You're jealous.
She lives in Colorado. Very jealous.
Amen.
It can be pretty fun. Colorado is a nice place. Okay, so let's go ahead and draw this triangle out. I'm going to state that the cops are up here. This is the way I'm drawing it. This right here, this is the cop car. Then the intersection is going to be right below him, right? Well, like it said, the speeding bandit has turned the corner and is moving straight east. So we're moving in this direction, right? So we're moving this way.
How'd you
Okay.
get to do that?
Straighten out.
Yeah.
Watch this. But yeah, didn't you see my amazing triangles before? Oops. No, wait. You have to only hold it for a second. Nope.
Yeah, this one.
Yes. Or like this.
Just squiggle. Whoa.
Let me see.
Perfect fit.
Some of us are just
Trapezoid. I don't need pen. Oh wait, that did work. Wait, it did work. All right, we're screw related rates. We are drawing trapezoids all day. No, come on.
Try like an octagon. Or like
Shot
a hexagon.
2 triangles.
Wait, like a star? Like how? What kind of star? Like this?
Like a 5-point star.
Oh.
Oh my
Oh.
You know, I just taught you all how to basically, with what I just taught you, you could go outside, measure the distance between you and a rocket launch, use your finger, say, okay, I'm moving like, let's measure this at like a couple centimeters per second. But this is what impresses you.
Yeah.
I taught you how you can measure the rate of the rocket. Okay, that's that.
Technology.
It's the worst part is it makes sense to me as to why. Oh man, so good. Okay, now let's keep going. So this is the cop. This right here is the intersection. Okay, so this is the intersection, and over here, this is the bandit. Do we all see how I made this picture right here? Okay. So because the cop is to the north, he's going towards an intersection. The bandit turned east. I don't mind if you flip it west. It's fine as long as only west is mentioned and not east, or east is mentioned and not west. And then we're here. Now the cop can still see the bandit, but that's from here to here. Okay. So here are our different parts. We have our y, our x, and this would be our z. So let's go ahead and calculate everything out. We know, what do we know? We know when the cruiser is 0.6 miles north of the intersection. So what's this distance?
0.6.
Then what is going to be the distance on the bottom? The distance is going to be 0.8. Very nice. And then what is z equal to? Well, I ain't got no clue what z equal to. There's no way we can find it, right?
Nope, no way.
Pythagorean theorem. So 0.6 squared plus 0.8 squared, and then take the square root of that is equal to c or z. Sorry.
I got 3.16.
Yeah, is it 1?
Yes. What is it?
Good. Okay. Actually, wait. Oops. I made a mistake. Z is equal to what?
No, it's 0.36.
0.36.
Wait, how's it on?
Oh, no, sorry.
The square root of
I was talking about
36 plus.
Now,
Yeah, it's the 5.3 triangle.
Square root of 1.
0.5 times 2 is 1. Is that plus 0.30?
Yeah, it's square root. Oh, shoot. I did that.
oh, nice. Okay. All right, because it's 0.3. Yeah. Okay. 0.36 plus 0.64. That makes sense. Because 6 squared plus 8 squared is 100.
Exactly.
That's just There we go. Okay. That makes more sense now. I hate this tie. I really like this tie, but every time I wear it, it always like goes sideways. I don't know why.
You just need to tape it.
I have. Don't make me think about it, okay, Caleb? So I know I just stuck it in. Okay, so I made a mistake here because I actually did the next step. Because what variable does it look too strange? Should I just go like maybe like this? So I can wear.
She has a tie clip.
I do have multiple tie clips. I just don't like wearing them. I don't know why.
Like ties on your neck.
Is it really? Oh, awesome. Okay, now.
Wait, now it's like.
Did I really put it on backwards? My goodness.
I'm telling you, tape it.
Just tape it. That'll be a lot easier.
It's too late.
I know, but it's if I go up here, it's just gonna keep flipping around. I don't. Yeah. Okay, so I input this, but I actually made a little bit of a mistake because if you look at 0.6 squared plus 0.8 squared is equal to z. We take the square root of that. We found z. But do I need z really? Do you think?
Probably not.
No. Because what do we need? So no, that's okay. So we know what z is. That's fine.
We just need the speed of
Lucy?
over charge.
So we need the speed. So therefore, what this is going to be our dx over dt over here, dy over dt over here, and this is going to be dz over dt.
Can we switch the X and Y?
Yeah, why are we doing it like that?
Oh wait, no, I did. No, I have the right y.
Just the trick.
Okay, just to trigger you all. Okay. So now remember, what am I trying to find? I'm trying to find the speed of the car. I'm trying to find dx over dt. Therefore, well, what equation relates all three of these variables? We already did it. We just used it in the incorrect way. The Pythagorean theorem. We get x squared plus y squared is equal to z squared. Then, can I take the derivative of this pretty easily?
Yes.
And remember, take it with respect to t. So therefore, this is going to be 2x times dx plus 2y times dy equals 2z times dz. And you can divide all of those by dt. So now we just need to start replacing things. Well, what is the rate? What do we need to solve for? We're looking to solve for which one? We're trying to solve for dx over dt. So what you could do is you could replace everything now, or you could try to solve it. I'm going to just go ahead and replace everything now. Okay? So, also, what can I do with the 2's straight away?
Cancel.
Cancel all the 2's.
Cancel.
Cancel. Cancel. So, what is x equal to? X equals 0.8 times, do we know dx over dt? Nope. Plus 0.6 times, and what is how fast is the car going? 60. However, this is where it gets a little difficult. Where is it? Where is the cop car going?
South.
It's going south. And what does south usually mean? It's going in a
Down.
negative. Yes. The velocity is negative because we're going 60 miles per hour towards the south. So this right here is going to be negative dy over dt equals, dy over dt equals negative 60, right there. dz over dt, this one doesn't matter. The reason that it doesn't matter is because it is it's more of a, yeah, it's hard to say. It's more of a, this is more of the speed. There's no directional way that we can say, oh, it's negative for sure, because it's going at an angle, so we'd have to use the angle to better describe it. Well, this here can be easily described with the angle. Caleb. All right, and so we have all this information. So this is negative 60 is equal to 1, which is our z value, times 20. Okay? So now we just simplify everything. You're going to get 0.8 dx over dt minus 36 is equal to 20. 0.8 dx over dt is equal to 56. Dx over dt is equal to 70. So how fast is the other car going? It is going 70 miles per hour. Well, the cop is only going 60. Now, obviously, what the cop should do is just, depending on what's through here, you should just burst through. I'll try to avoid civilians and drive straight down that way.
Straight through the city.
Well, I mean, look at it. Dude, this guy's gonna get away. He's going 70 miles an hour. This guy's going 60 miles an hour.
Car can go
And you're gonna have
way
to. I mean, how much do
Straight
you?
through the building.
What is?
Is it really worth risking the lives of innocent civilians?
Yeah.
I mean, how bad is the bandit? Like, how much did he annoy the cop? Honestly.
Bro, it's in like a
Literally.
helicopter.